Question number 9. Ozone gas becomes oxygen gas. So for this question, this is actually a spontaneous reaction. So let's calculate the enthalpy first. So delta H is going to be, so for oxygen gas, it has a standard, it's existing in its snare state, right? Oxygen exists as oxygen gas. So its heat of formation again is 0. So we're only looking at the ozone. Remember that's negative, right? Remember for reactants it's negative coefficients, for products it's positive coefficients. So this is going to be negative 285.4 kilojoules. We're not going to be calculating any bond energies because ozone, as you remember, has resonance structures, right? So it's neither double bond nor is it single bond. So we're not going to be worrying about that. Let's calculate the delta N of the gas, the change in the moles of gas. So it's going to be from 2 moles to 3 moles. So this is going to be plus 1. So work is going to be negative delta N RT is going to be negative work. This is going to be about negative 2.5 kilojoules. So this is work done by the system. Now let's calculate the delta N of the system. So delta N of the system is just going to be the same thing. It's going to equal delta N of the gas, just plus 1. Let's calculate the entropy. So it's going to be 3 times 205 for oxygen gas minus 2 times 238 for the ozone. So that's going to be 137.56. Let's calculate T delta S. That's going to be 300 kelvins. Remember this is joules per Kelvin times 137.56 joules per Kelvin. That's going to equal about 41 kilojoules. And so delta G is delta H minus delta T minus T delta S is equal to about minus 236, about minus 326 kilojoules. So as you can see here, we have a positive entropy change. So we became from 2 moles of more ordered molecules to 3 moles of more disordered molecules. So entropy here was positive. And as you can see here, this reaction is spontaneous as we predicted. So delta G is less than 0, is negative.